Revision of number patterns. Consider the number pattern -1, 5, 11, 17, and so on. If the difference between any two consecutive terms is constant, the pattern is linear. Recall the V-shaped flying pattern of geese that we learnt in grade 10. The general term for the linear pattern is given as Tn equals Pn plus Q, where P is the constant difference and Q is a constant. Let us now represent the relationship between the nth term and the number of terms on a graph. Note that the number of squares is the independent variable x, and the number of matchsticks required is the dependent variable y. When x equals 1, y equals 4. When x equals 2, y equals 7. When x equals 3, y equals 10, and so on. We now plot these points on a graph and join the points using a broken line. The independent variable is the number of squares, since it is varied by us. The dependent variable is the number of matchsticks, as it is the variable that we are interested in finding. We can see that the graph is a straight line. The graph denotes a linear relationship between the variables. Now, we shall revise quadratic patterns with the help of the following example. The pattern for the number of handshakes when the number of learners increases from 1 to 6 is shown here. We can see that difference of the terms of this number pattern is not constant. In fact, it is actually forming yet another pattern. We call this the first difference. The first differences form a linear pattern. We now calculate the difference between the first differences. We find that the second differences are constant. If the second difference of a pattern is constant, the pattern is quadratic. This is the signature of a quadratic pattern. Let us briefly revise the properties of a quadratic pattern. The general term for a quadratic pattern is Tn equals an square plus bn plus c. Second difference is 2a. First term of the first difference is 3a plus b. First term of the quadratic pattern is a plus b plus c. Let us now analyze the pattern and describe the relationship between the number of terms, that is, n, and the nth term using a graph. 0, -2, -2, 0, 4, 10, 18, 28. Let us find the differences. We observe that the differences are not constant, but form a linear pattern. The second difference is constant. Therefore, the given pattern is quadratic. Now, plotting the numbers in the pattern against the term numbers, we get the graph of a quadratic pattern is similar to that of a quadratic function.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.